Let's move on to our second speech given by one of our very own seniors, Lasa Hettiarachchi, who is a fourth year software undergraduate at SLIIT, Microsoft Learning Student Ambassador, and the president of the MS Club of SLIIT. Lasa, the screen is yours.
Right, thank you, Savina. Just let me share my screen as well. Is it visible now? Can someone confirm whether the screen is visible?
Yes, Lasa, it's visible.
Sure, thank you. So yeah. Nilesh, that was a really insightful session on Kubernetes. We also learned a lot. So we plan on doing our research based on Kubernetes as well, and that was an insightful session for us as well. So yeah, so moving on. So who am I? So I'm a fourth year SC undergraduate at SLIIT. I'm also a second year physical science undergraduate at University of Colombo, and I'm the current president of MS Lab of SLIT. So you might be wondering why the hell is a guy from SC doing a session on machine learning, right? So as I said earlier, so we are doing our research on Kubernetes, and in that research, so there is a machine learning component, and when we really dive deeper into what is out there, the technologies that are out there, we found that so to get an initial idea on to enter the machine learning domain, it's much easier to use a platform such as Microsoft Machine Learning Studio to get that out, to put that foundation first and build upon that and so on. So I'll be showing you how to really get started with machine learning and how to use Machine Learning Studio to get yourself up and running. So first of all, so if you look at what machine learning is, so if you go for a formal definition, you see that. So just give me a second. So so the formal definition given by Tom Mitchell, who's a lecturer at Carnegie Mellon University. So he says that a computer program is said to learn from experience E with respect to some task T and some performance measure E if its performance on T is measured by P. Measured by P improves the experience E, right? There is a lot of letters going here and there, and I mean, it's kind of hard to get the actual meaning of this definition, right? So let's turn it down a notch and let's go for something simple, right? So what is machine learning? Basically, in machine learning, what in my perspective, what machine learning is that you are giving the computer some set of rules, and you're asking the computer to come when you give a data set, you're asking the computer to give you some inferences based on that, right? So for an example, let's take this as an example, right? So this is a data set data representation that is representing the house prices in a certain area with against the area of the house, right? So for an example, if you take this data point, let's say that this data point's x-axis is 495 and its price is around somewhere here, right? So when you have a price if you have a house that is 495 square feet, let's say, it generally, so these data are collected by actually doing a survey or something, and based upon that, what machine learning does is it tries to predict the actual price of a house when you say, so let's assume that your friend wants to buy a house in this area, right? So your friend Kamal wants to buy a house in this area. So what we can do is we could build a machine learning model which predicts the prices in the house when we input this area of the house. So that might be a linear. So if you're good with maths, so you might be able to follow, but it doesn't really matter. But so if you could fit a polynomial function here going like this, or you could fit a linear function going like this. So we'll get back to that. And what it will do is, so let's assume that your friend's house has 1,200 square feet. So we go along this axis and find uh, the actual price of the house. So this is the basic idea of what machine learning really is. So in its core, what we're really doing is we will provide it with a data set. We will put it into a machine learning algorithm, and we will create a hypothesis. This is basically a machine learning model which predicts when you input the size of the house, it will provide you with the estimated price. So there's unsupervised learning. We'll get back to that. So I used a lot of machine learning jargon in my previous explanations, right? So before going into the actual machine learning studio demo, I believe that it is really necessary that like since most of you guys are new to machine learning, I believe that it is much more insightful if I go through this jargon, right? So some of you might be new to this. So there's supervised machine learning, so there's unsupervised, so there's labeled data, unlabeled data, classification, regression, clustering, labels, features, models, right? There's a lot of jargon going out there. So let's take it one by one and let's try to understand what they are, right? So this is basically the outline of machine learning. So there's more stuff than this. So for a beginner, this is quite enough. So let's start with supervised machine learning. So as I said earlier, supervised machine learning, if I take this example back again, what we're really doing is we are providing the area of the house along with the prices of certain houses, right? So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. We are providing the area of those 11 houses along with the actual prices, right? We are providing them. And what we are doing next is we will give an unknown output. So let's assume it's 700, and we try to predict the price of the house, right? That's what we are doing. So if you go back here, what we are providing is the data training input set, so which is basically the area of the houses. So that might be many features. We'll get back to what features are, and it might be like the area of the house, the number of bedrooms of the house, and so on and so forth, right? So the training input data set might not be just one feature, it might be many features. And what we're doing is we will predict a certain label out of that, right? So in this case, what the label is the price of the actual house. So we provide both of them, and we use a machine learning algorithm. So in this example, what we used was a regression. This is a regression problem where we predict the value of a continuous variable using so we take price as a continuous variable and we try to predict it using the values of the features, right? So that is what we are trying to do. So we provide it with a machine learning algorithm. There are many machine learning algorithms. You get to learn them if you like really go deeper in this, and you create a model. You create a machine learning model, which is our hypothesis. So if you are good at maths, I'll get back to a formal explanation. And what you are doing next is you provide it with the input data set, and using this model, you get the output data. So this is the value that you are inputting, the house of the area of your friend's house, which is 700 square feet, and you get the output as let's say 110 US dollars, and so on, like that sort of a thing. But there's another domain called unsupervised machine learning, where you only give the computer the intended data set only. You don't give the actual labels. So in this case, we gave both the area and the price of the house, right? But in this, we don't give the inference that you want to make. So you look at a proper example data, and it will be inputted into an algorithm like k-mean, and it will also create a model, machine learning model, and you can input certain data and it will give you an output, right? So that is basically unsupervised machine learning. So if you look at here, so this is kind of a toned down example of unsupervised machine learning. So what you are basically doing is, so if you assume that you provide this raw data set, right? These are unlabeled data, so we haven't separated these as apples, strawberries, and so on, pears, and all that. We just give this data set to the machine learning algorithm, right? And the computer figures out that these three and these two are similar, and it clusters them together. So the computer figures out that these apples have certain features that are similar, and they what they do this is they cluster them together, right? So they cluster it together, pears in the same manner, and strawberries in the same manner. And what when we input another picture of a pear or an apple or a strawberry, the machine learning algorithm can actually figure out whether it's an apple or a pear or a strawberry. What's different from supervised and supervised machine learning is, so in supervised machine learning we don't give a raw data set, we give a properly labeled data set. If in supervised machine learning, if you were to give this data set, we will label this is an apple, this is an apple, this is an apple, this is a pear, this is a strawberry, and so on, right? But in unsupervised machine learning, we give them the raw data set, and the computer figures out what the similarities between them and cluster them together. So if you look at this example, the same thing has happened. So computer finds a certain similarity between the data set out here and so on, right? So this uses the k-mean algorithm to do this, right? So that is basically it. So we are done with supervised machine learning and unsupervised machine learning. So we'll get back to labeled data and unlabeled data here. So in labeled data, so in label data, so if you look at this data set, so these pictures are labeled as this is a dog, this is a dog, this is a cat, and this is also a cat, right? So in this data set, each of these pictures are labeled according to their weights, right? So this dog is 18 pounds, this one is 14 pounds, this one is 12 pounds, and this one is 4 pounds, right? So, but in an unlabeled data set, what happens here is we don't give labels, right? We don't give this one is a dog, this one is a dog, and this one is cat. Or we don't give the weights of these data set. We just provide them with the data set, and the computer has to figure out the similarities and the dissimilarities between them and cluster them together. And that sort of a idea is incurred by the labeled and unlabeled data. And classification, regression, clustering. So these are mainly the domains of machine learning if you take the whole picture. So we'll take one by one and try to understand what each of them are. So if you are interested in learning machine learning, so there's a great course on Coursera by Professor Andrew Ng, who's a lecturer at Stanford University. So I took this slide out of his. If you look at this one shows the example that I explained earlier, right? So this one shows the price of houses in a certain area graphed against its area, right? So if you look at this example, so there are data points of certain houses and the value of each house, right? So if you look at this, so let's assume that this one is 490 and the value is $110,000, right? So what we do is we fit a mathematical representation that best represents these data sets, right? If you look at this, in my perspective, a linear function doesn't fit the data set properly. But if you, in contrast, if you plot a polynomial function here, it sort of best fits the data set properly. And what you can do here is you input the unknown value. So you assume that your friend's house is 750 square feet. You go along this line, and the point that this line cuts the mathematical model that you have built, it gives you it provides you a predicted price that you can that according with a certain error associated with it, right? So that is what a basically a machine learning model does. So if you take regression, so that's what we are trying to understand here, right? So in regression, what we're trying to do here is we try to predict a value of a continuous function. In this case, price. So we assume that price is a continuous function, and what we're trying to do here is we try to predict the value of that continuous function using the value of certain set of features. So in this case, I took only size of the house as a feature, but there might be instances where the number of bedrooms in the house might come into play, right? So in that case, what if you can actually visualize this? So if there are two sets of features, so there's size of the house in feet, and there's the number of bedrooms. So take an z axis along this line, and you can sort of graph a 3D based graph in a 3D space, which we and fit a 3D a function which best fits the data points, right? So that is when you orchestrate it to a two feature data set, and you can go with any number of features. So if I go for a formal definition, so what we are doing is, so assume that what you're trying to predict is the price of the house. Let's say price of the house, right? So assume that x1 is the area of the house. Let's assume that x2 is let's assume number of bedrooms. Let's assume x3 is size of the kitchen, right? What we're essentially trying to do here is we try to predict the value of y, which is our unknown variable, using a function which we take as f. So these are hypotheses. These are also the machine learning model that we're trying to build using the values x1, x2, x3, right? So this is what we're trying to do. This is basically machine learning, right? So coming back to the presentation itself, so this is regression, and we'll move on with classification problems as well. So let's try to understand where classification changes from a regression problem, right? In regression problem, I said that we are trying to predict the value of a continuous variable using a set of features, right? But in contrast, in classification problems, what we are trying to do is classify a label, right? So I'll explain using an example. So in the medical field, there's a really popular example. So we could use machine learning to figure out whether so one of the major problems in the medical field is detecting whether a tumor is a malignant tumor, which basically means that the tumor is harmful, or it is a benign tumor, right? Which basically means that it is not that harmful, right? So that is an actual problem existing in the medical field. So you could use machine learning to actually predict this, right? So what we do here is we actually get a data set of malignant tumors and benign tumors, and we measure the size of the tumors, right? So assume that this one is let's assume that 2 centimeters, this is 3 centimeters, this is 4. So these are malignant tumors, and this one is a benign tumor. So there is a data point saying that 5 centimeter, there's a 5 centimeter tumor which is a malignant tumor, and there's a 6 centimeter tumor which is not a malignant tumor, which basically means that it is not that harmful, and so on. We plot this, and what we do is we train a machine learning algorithm. When we input a size of a tumor, the machine learning algorithm has to predict the probability whether it's a malignant tumor or a benign tumor. This is what a classification model does. So that is classification. That is classification. So clustering basically means the example that I gave here in unsupervised machine learning, where you try to figure out certain similarities between the data set and you try to cluster them together. So that is clustering. And as I explained, labels are the things that we input to the machine learning algorithm. These ones, labels are the things that we try to predict, and feature sets are the things that we input to the machine learning algorithms through in order to predict this value. So that is basically labels and features, right? So yeah, we were here, right? So there's a lot of theory thrown out here, right? So you might not actually get this, but since some of you might be interested in what machine learning is, so I gave you a small introduction to what actually meant by this, right? But if you are trying to build, if you're someone like me who's a software engineering student who doesn't have a background from machine learning, you could use Azure Machine Learning Studio to get these things done, right? So I'm not that good at coding. I'm not that good at coding a machine learning model yet. So I have to learn that. But before learning that, what we can do here is there are already existing solutions provided by Azure. You could use them in order to build up a machine learning model, right? So let's do this using Machine Learning Studio. So first of all, what I'll do here is I'll go to the Azure portal. Portal. Right. So this is basically Azure portal, which is the collection of services provided by Azure. So there's Kubernetes service. So what Nilesh explained. So you could go to here and discover more services. You could fire up a virtual machine. You could go to Azure Cognitive Services and use that to power your application with Face API, sentimental analysis, and all that. So there's a lot of stuff out here. So I highly encourage you to go discover this. And if you are a student, so there is $100 Azure credits that you get to explore this. So I highly recommend that you use that as well. So what I'll do here is I'll create a machine learning instance here, and yeah. So when you go to machine learning instances, you basically you have to give your subscription here, and you have to provide the resource group. So I'll create a new resource group. I'll put it as let's give it as MS Jams demo. Right. So let's give it as that, and I have to give a workspace here. So I'll give my IT number as my workspace. So yeah, and it asks you for the region that these instances are created, right? When you create a machine learning instance, there are certain compute instances that are created along with it. So this is basically the region that the compute instances will be created. So I highly recommend East US, and so there are certain other regions as well, but this doesn't really matter if yeah. And what I'll do next here is I'll review and create. So this might take a little time depending on the yep. In the meantime, do you guys have any questions? I believe no, right? If you have any questions, please do send it on using the Q&A. So it will take some time to deploy actually. So this will do is it will create a machine learning instance in Azure. Yep. Just give it some time and it will be created. Guys, if you do have any questions, please do send it using the chat box so I can answer them in the meantime while it's being deployed so that we don't waste any time. Right, what I'll do here is I'll until that gets deployed, I'll use an existing existing instance, and I'll explain. The deployment is complete, so we don't need that. So I'll go to so this is the page that I was basically in. So I'll go to my resource, and I'll learn machine learning studio. So what Azure has done here is, so there's a lot of services that provided by Azure, right? So there's machine learning studio, there's cognitive services, but what Azure has done here is, so they have integrated all the machine learning components of their service into something called a machine learning studio, where you could easily access all the things that are necessary to create and deploy a machine learning model together, right? So if you look at the interface out here, so there's notebooks, there's automated ML. I'll get back to what these are. So there's data sets, there's experiments, there's pipelines, endpoints, computes. So everything that a that a data scientist needs to create and deploy a machine learning model, they have integrated into one place, which will help you, like, to keep track of them, right? So why does something like this needed, right? If you look at the machine learning domain, what actually happens here is, so there's data scientists, and they get a data set, and they look at this data set, and they have to take a lot of time pre-processing this data, clearing out missing variables, then normalizing the data, and so on, then building the machine learning model itself, and then deploying it. That's a lot of effort if you do it manually, right? But what Azure Machine Learning Studio has done here is, they have basically simplified that process, and they take care of the pre-process. They basically provide a service where they take care of the pre-processing of the data, the creating of the model, the deploying of the model. If you want, you can do it manually using notebooks. You could actually write. So if you are familiar with Jupyter notebooks, this is basically something like that, where you could create a notebook and write code here. You could write code here. If you want, you can write. If you want, you can do that. But they have provided other services where they take care of that complexity, and they handle that in the backend itself. What we have to do is, we just have to provide them with what is necessary to be predicted, and they take care of running several machine learning models and comparing them and giving us the best machine learning model. That they basically do, right? So that is what they have actually done. We'll look at what these three are. These three are the basic tools that you can use to interact with this interface. First of all, we'll try to look at what automated ML is, right? So automated ML. So I'll take a small example uh, from their documentation as well. So if you are learning machine learning, I highly recommend to use the Microsoft Learn platform, which they provide the basically with examples, and they guide you through each steps necessary to properly use Azure platforms, and so on, right? So I take this example, right? So this is basically an example of a bike rental place. So if you have been to Nuwara and near the Gregory Lake, so there's a bike rental place where you could rent a bike and go anywhere, and you could return the bike, right? So this is basically that. So from the perspective of an owner, you want to predict the number of rentals that is happening on a certain day from a set of features, right? We'll look at what those features are. And yeah, so we'll go to next. And we'll look at this data set, right? So these things, they guide you through how to properly set up the machine learning instance, and so how to properly get a compute instance up and running. They provide you with everything, right? So I won't go through that. I'll just I'll open this data set. Downloads. right? I take this data set as an example, right? So if you look at this data set, so this is basically a CSV file. So if I input it to numbers, it basically gives me a set of a table basically. So if you look at this data set, there is the rentals, right? So so from the perspective of the rental place owner, this is what you are really concerned about, the number of rentals. If you give a particular day of a particular month, the year, and so on, with the whether it's a holiday, whether and so on, you want to basically get the number of rentals, right? So that you could prepare and get those bikes beforehand, right? So this is the important factor that we want to predict, right? So this is the label of our data set, right? So, and these are, so if you look at this, the day, so there are around, I believe, 700 odd, yeah, the count is 732. So there are 732 instances, right, of data, right? So they have 732 days, and it has given the month, right? So this is January, this is February, 2 is February, 3 is March, and so on. And they have also given the year. This is 2011, this is 2011, and if you go down, this is 2012, right? They have basically arranged that accordingly. And this is the season. So there are spring, autumn, summer, and there's winter. So based on that, so that might affect, right? So in winter, people don't go cycling, right? So that might be a factor that is affecting the rentals. So they have given it as a feature, and they have also given whether it's a holiday as a feature. So if you look at this, these aren't holidays, so they have been notated as zeros, and this is a holiday. And whether it's whether the day of the week. So this Monday, this Sunday, this Tuesday, Wednesday, and so on, right? So whether it's a working day or a holiday, I don't know what weather it is. I don't know what that is. And there's the temperature. There's the hum, there's the wind speed, and so on. This is basically a data set, right? So what we want to do is, using these feature sets, using this set of features, we want to predict the number of rentals. So assume that, so this is 2020, so today is January 9th, right? So we want to input these data. January 9th month is 1, 2022, the season is something, let's say fall, whether it's a holiday, whether it's a weekend, we will provide this set of data, and we want the number of rentals that is predicted by the model, right? This is what we basically want, right? So since we are predicting a continuous value, in this case rentals, we take this as a regression problem. We basically take this we have broken it down and reduce this to a regression problem, right? So that is what we are basically doing. So what I want to do is, so if I input so coming back to numbers, if I input these set of features, I want to predict the what you call the number of rentals. So we'll go back here, and what I'll do is I'll go back to Machine Learning Studio, and I will import the dataset. I will import my dataset into this. So there are several ways that you can import the dataset. So you could either provide a local file, or from a data store, or from a web file, and so on, right? I'll go with a web file, and I'll provide the link that they have provided here. So this is basically an online dataset that they have hosted, where you could use, right? So I'll provide it here. Name of the dataset is bike rentals. Bike rentals. So this is tabular. Basically the dataset is a tabular dataset, right? So the description of the dataset is bicycle rental place. So I want it as a tabular dataset. So that's why I have given it as a tabular dataset. And I'll give you the description, and I'll go next. So here, so if you are familiar with data processing softwares, so when you import a dataset, they ask you for a certain set of parameters that in order to import the dataset properly, right? So the the file that they have provided is a CSV file, which basically means that it is comma separated and there's a delimited, right? So it's not a plain text or a JSON or a, I don't know what that this is, but it's not a JSON or a plain text, right? It's a delimited and it's delimited by a comma, right? It's not delimited by a tab where you basically keep a tab space in between data, right? So what they have done is they have provided a comma and they have delimited the data. And use UTF encoding and only in the first files, skip rows none, and yep. And we'll go with next. And basically they identify the headers that are in the dataset. So if I show you, so there's month, year, and so on. So they have provided it here, right? Date, month, so on. They have identified them, and we could import it. Right? I'll import it. I'll basically create the dataset. There's a question. So can you give more details about ML? Yeah. So if you go to Coursera and if you type in machine learning, the top course that comes is the machine learning course that is provided by Professor Andrew Ng, right? That is one of the best courses that I've actually followed, and I highly recommend anyone who's coming into machine learning to follow that course. He basically explains it from a mathematical and a statistical standpoint, and it goes deeper. Yeah. How far can we go with Machine Learning Studio? You could. So Machine Learning Studio is basically for everyone, right? So from a beginner to an actual expert, you could use Machine Learning Studio because it provides. So if you look at this, so the dataset is important. I'll show here. So these the notebooks, these are actually sort of like Jupyter notebooks where you could write actual Python code. Let's say print. Right. So I have to create a compute instance first. In order to run that, I'll show you when I create a compute instance. So these basically are cells where you could run actual Python code here, right? So basically, Machine Learning Studio and there's an option for automated ML which we are trying to do. I'll demonstrate it. It is for absolute beginners where everything is done by Azure themselves, rather than we having to pre-process the data, normalize the data, and so on. They actually do it for us, and they will run several machine learning algorithms and provide us a comparison between them, and give us the best machine learning model that, and we could and go on and actually deploy it and use it using an API, right? So I'll show you how to do that. And there's machine learning designer. If I have the time, I'll demonstrate this as well. So this is basically a drag and drop solution where you could so there's I'll show you. So basically sort of like this sort of one, where you could drag and create a machine learning model out of that, right? This car changes. We'll go with OK, right? So that is basically it. Yes. So that was that question. Use to start machine learning. Sure, actually you can. I recommend you to use the follow the Microsoft Learn platform, and they provide you with quite an insightful guide to actually getting started with machine learning. Can you give us the link that you have mentioned in the session? Sure, I'll give you the ML link. I'll put it in chat so that everyone can access. Right, go to this link and where you could actually, so there's a lot of stuff here, right? So if you want to actually learn how to build a chatbot, so there's resources for that as well. So this is one of the most friendliest places you could actually learn new stuff. So I highly recommend checking out Azure Machine Learning, MS Learn platform. And we'll go back to the demonstration. So If I go back to dataset, you can see that the dataset has been imported. And if you go to explore, it takes some time since it is running on the cloud. And it will provide me with the same dataset that I downloaded, right? So this is basically this dataset, right? That one, yeah. So yes, so coming back, what I'll do next is we'll create the compute instances, right? The compute instances are basically virtual machines where you could use to actually run your machine learning models. So for an example, so if you code with Python and if you are running it on a local machine, when you actually run the cell that is creating the model, it runs on your local machine, right? But since we are dealing it with since we are doing all of this in the cloud, we have to create a virtual machine from Azure themselves and go from there, because our models will be run on a actual computer that is built on uh, Azure. So if you go to new, so it will take some time loading. I'll give the name as, I'll give my IT number again. That doesn't really matter. You have to give something unique here. So this is basically the name of the computer. The location is East US. The virtual machine type, I'll give it as CPU. And these are the set of virtual machines you could prepare, right? If you look at this is the 4-core 14 GB RAM machine with 28 GB storage, right? And it will cost you $0.29 per hour. If you look at standard DS11 V2 version 2, it is a 2-core machine with 14 GB RAM and 28 GB storage, right? This will cost you 0.88. And I'll just go with I'll go for from all options. I'll go for this one, and yeah, this is a 4-core machine. Sorry, 2-core machine. I'll go with that. I'll create. So until that is being created, I'll go for cluster, compute cluster. So this is basically where your actual model will be trained, and your machine learning algorithms will be run upon, right? So I'll go with CPU, ECUS, and select from all options. Again, go with standard V2. Compute name, I'll give it as cluster. Doesn't really matter. Cluster, yeah, minimum nodes that will keep as 0. We'll take this up to 3 nodes. So if you were listening to that last Kubernetes explanation, so these are basically nodes that are being created, right? So this is basically the nodes that are being created in a Kubernetes service. The number of nodes, idle time, we'll keep it as that, and we'll create. Right, this will start creating your instances, right? So this is still being created. In the meantime, what I'll do here is I'll go to automated ML and I'll start a new automated ML, right? So this is basically you saying to you saying to Azure, so I don't know a lot about machine learning. I'll give you the data set. I'll provide you. I'll provide you with my data set. I'll provide you with what I need to be incurred, and just basically do the processing data and building the model part from your end, right? So that is what we're trying to say. So what I'll do here is I'll provide you with my bike rental data set. I'll go with next. And yeah, it takes some time. I'll create a new experiment. I'll put it as MS Champs demo, right? The target column is, so I want to predict the rentals, right? So I want to predict my rentals. So from the perspective of the owner of the bike rental place, I want the number of rentals given these set of features, right? So that is what I want to predict. So I'll give it as rentals. So select the column type. It is compute cluster. So the compute type. So this is basically the compute that I have created. So if you look at this, my compute instances have been already created and successfully provisioned, right? So what I'll do here is I'll put next. And this is where you have to provide whether the algorithm that you want to run, whether you want to run a classification algorithm on your dataset, whether you want a regression algorithm run on your dataset, and whether you want a time series forecasting run on your dataset, right? So this is what you want to do, right? So if you go, so I want to run a regression model on my dataset, so I'll click regression and go to enable featureization. This will enable featureization for me, and I'll go for additional configurations, right? So this basically gives me the parametrics that I use to validate. To test how effective is my actual machine learning model. So if I go give it as normalized root square error, that will use that in order to detect how accurate is my algorithm. You could use P-evans correlation, you could use R2 score, you could use normalized mean absolute error. So I'll go with normalized root mean squared error. And so these are basically the list of algorithms that you can block when you are actually running it. So if when I click regression, so these are the set of regression algorithms that Azure Machine Learning provides, right? So there's elasticnet, there is random forest if you recognize, so there's like GBM and so on, right? So there's fast regression, so there's XG boost regression. So if you are good with machine learning, you know these stuff, right? So I'm not that good with machine learning. I'll put some of these in. And I'll go with linear regression and light GBM. So these two, linear, so light GBM and I'll put fast linear regression as well, and I'll remove random forest. So random forest and light GBM are the two machine learning algorithms I want to run on my data set, right? So these two will be the only algorithms that I want to run. So if you want to run everything, you can basically input nothing onto this field, then it will run all the algorithms and it will compare between them and provide you with the best algorithm. So I'm assuming that these algorithms won't provide me with the best model, so I'm basically neglecting them, right? So you could provide the exit criteria. I'll provide the exit criteria as give me a second. Hmm. 0.5 and 0.08. So I'll provide the exit criteria as .08, right? So this basically what this does is this will run my training model for only half an hour. So this is inputted by hours, right? So when I give 0.5, so this will only run for 0.5. Or if you can find a machine learning if you can build a machine learning model with this error with an error less than this one, right? This is the threshold value. So if the error is less than this one, the training process will stop, right? That is what basically happens. So I'll hit save. I'll go with next. Auto validation on. So this basically uses this basically correlates with the validation of our data set, right? So in machine learning, what we will do here, is we will provide a certain set of data to train the machine learning model, and we will provide it with another data set in order to validate whether this machine learning model is predicting properly, right? So that is what we basically do. If you are into machine learning, what we do is we split our actual data set into so the ratio that we are splitting might be different. So what we usually do is we split the data set into 80-20. which basically means that we use 80% of the data to actually train the model, and we use 20% of data to actually validate the model, right? Or if you don't want to do that, what you could do is you could use all the data to train the model, and you could use and you could provide another data set in order to validate the model, right? So what I'll do here is I'll finish the process, and this will get it running. It is validating the data, and this might run for a while, right? So the status is not started, and this might run for actually a long time, right? So what I have done here is I have already, so it will take some time. So what we'll do here is we will I have already actually trained the dataset for you guys previously, because this is actually run for around half an hour, and it will train the dataset, right? So we cannot wait that long. So this status is actually changing from running to training and so on, and this will come to completed. I'll show you a dataset which is completed, and yes, I gotta go here. Launch ML Studio. If you go to experiments, yes, automated ML. So this one is actually completed, right? So I followed the exact steps that I've gone through when I did my job, and what it has done here is, so it has basically trained the whole thing, and this has been completed, right? So yeah, and they have given the best model that they are proposing as max ABS scaler, which is a light GPM algorithm, right? So yeah, so if you look at this, so we gave the exit criteria as 0.08, which is basically greater than this. So this achieves our exit criteria, which basically means that our algorithm is correct up to this sort of a error, right? So yeah, and if you look at this, if you go to metrics, right, if you go to predicted values, and these will give you an insight onto how correct a machine learning algorithm is, right? So this, if you look at this, so this is the ideal data set, and this is the actual average predicted value, and this will give you sort of an inference onto how accurate your machine learning model is, right? So if you go back to models, go back to, let's say, this one, and go back to models, you could see that there are several machine learning models that the computer has tried. So there's max ABS scaler like GBM, sparse normalizer like GBM, standard scaler wrapper, right, like GBM. So there are several models that the computer has created, right? But if you look at here, the normalized square root mean, right? The least error we get from this one, right? That's why they are predicting this as the best machine learning algorithm, right? So yeah, right. So we did that, and we'll go back to actually we've what you called trained a machine learning model. Next up, what we have to do here is we have to actually deploy a machine learning model, right? So this is basically in Azure Machine Learning Studio, right? But if you look at it from a software engineer's perspective, we want these APIs to be exposed to the public, right? So we want so what we want is we want to give these set of features, right? We want to give these set of features, and we want the application to predict this. Let's assume that, right? So we are building an application which can predict the rentals based on a set of features, right? So we cannot actually input them into we cannot go here. to Azure Machine Learning Studio, and we cannot input them, right? So we need another method to do that, right? So what we can do here is we can actually deploy this already created machine learning model, and we could access them through an API. Using an API, we could access them, right? So what I will do here is I'll go to models, I'll go to LightGBM, and I'll deploy it as a web service, right? Then they ask for the name of the web service. Right. Then we are going for deployments. So I'll give the name as predicted rentals and description as predict cycle rentals. The compute instance is Azure Kubernetes. So you could either go with Kubernetes service or container instance. So container instance is much more cheaper than Kubernetes service. So I'll give it go with container instance, and I'll enable authentication, right? And I'll deploy it. Yep. So this will also take some time. This will deploy my machine learning model. So it says that it is in progress. If you look at here, the prediction model is running. So what I'll do here is I'll show you an already deployed machine learning model so that you could get an idea how that works, right? So if I go to endpoints. So this one was created now, this one I did earlier. So if I go to that, this one is already deployed, right? If you look at this deployment state, it is already healthy, right? If you go back to the one I deployed just now, the container deployment, it is transition, right? If you hover over this, it will give you what that means, right? Transitioning means that the state is in process of deployment. So we'll go back to endpoints and we'll go back to the rentals, right? So we want to actually access this from a third-party application, right? So what we'll do here is we will go to consume, and it will give you sort of a demonstrated code which you could use in order to actually access this data. So you could change it to C++, Python, or you could use, so they have given demonstrations from these languages, but you could use many other languages as well, right? So if you go with Python, they provide you a demo set of code into how to access these APIs using a third-party application, right? So if you look at this, they take the request data. So these are basically the set of features for the day that we want to predict, and what they will do is they will predict the label, right? So I'll get back to that, and this will provide the API URL and the API key, and these are basically, this will append the API key to the back of the header, the token to the bearer, and it will trigger the request to this backend, right? So that is basically what is happening. So we will actually test our model, and let's see whether it's working properly, right? So what we'll do here is we will go to notebooks, right? We will actually take another instance. We will go to notebooks. So we have actually done it, right? We will go here, notebooks, right? So I could actually show you this one as well now, since I have created a compute instance. So if I click here, it will take some time in order to run it. I don't know why it's taking that long. So it basically is this is basically an area where you could write Python code, right? So you could take it as that. So what I'll do here is I'll use the code in order to actually what you call the trigger request to my deployed model. So I'll paste a pre-prepared code. So I'll go through the code. Don't worry. So what we'll do here is, so this is basically a code where it will. So this is a 2D array. So this is a set of features for a given particular day. So let's assume that this is day 1, right? So this is day 1. So this is day 2. This is day 3, and so on, right? We have given 5 days, and we have wrapped all that into another array. So this is basically a 2D array, where in each array they have provided with the set of features, so that we can predict the value of the label, right? So which basically means that when we give, when we provide numbers here. So we have given 5 days. 5 days in the sense we have given certain unknown 5 days, right? So these are known data, but assume that these are unknown data, right? So we have given 5. We have taken 5 days, and we have given the values corresponding to each of these set of features. And what we want to do here is we want to predict the number of rentals for each given date, right? So that's what we want to do. So we have given the set of features, and we want that to be converted into JSON, since we are dealing with a REST API. So we want that to be converted into JSON, and we take that as this variable. And what we do here is we specify the key and the endpoints, right? Here. So I'll change them. So I'll delete these instances. So these things you don't want to be exposed publicly, right? So for the demonstration purposes, I have given it out here, but I'll delete my instances. So for the sake of the demonstration, I have provided them publicly, but these things you don't want to be exposed to the public. These must be kept secure, right? So what they have done here is, so I provided the API key here. So my primary key, and they have appended it into the back of the bearer. And they have created a post request to my endpoint, inputting these set of data, inputting these set of JSON data, and giving the header as that. And they have but if the response is 200, they have decoded the JSON file, and they have print my predictions nesting through that cursor, right? So that's what they have done. So what I'll do here is I'll provide my API, provide the API. So we'll go back to endpoints by rentals, consume, and I'll copy this API and provide it here, and there's the primary key, right? I will regenerate it. This might take some time. So they said that actually the model that we have actually deployed has, that's healthy. So we could use this as well if you want. So we'll copy this REST API and we'll provide it here. Command V, and we provide the what you call the API key as well, and the exact same code, and I'll run it, right? And this predicts the set of rentals given the set of features, right? That is what they basically do, right? So that is what is happening. So if you provide the set of features, they will predict the label set, right? That is what is happening here. So up to now, are there any questions, guys? So let's go back to Teams.
No idea.
No, right? So there are no questions up to now. Right. So I'll. So if you want, I could go with. So I've covered automated ML, and the notebooks. So notebooks, I didn't go deeper. I just used it to demonstrate how to access an endpoint, right? But there's a lot of stuff if you are good with Python, if you can, uh, uh, I mean, create a machine learning model on your own based on your Python knowledge, based on your R knowledge, or based on if you're good with statistics and mathematics, you could actually create a machine learning model on your own by writing Python code here. But if you are not that good with Python, you could use automated ML, and you could basically let Azure handle the complexities behind that, and you could just provide them with the dataset, and they will create a machine learning model for you that Azure handles. So if you want, I can give you a small insight into what designer is, but if can you guys reply on chat, right? What do you guys want? Do you want me to cover that as well? Or is that enough? So we'll publish this. Can someone reply on chat? So by the way, if you guys have any questions regarding any aspect of Machine Learning Studio, please do put them on the Q&A section. I'll surely answer them. Sure, I'll explain that. Sure. So yeah, so I'll log out from my account and log in from my IT account. So just give me a second. Right. Right. So I have already designed a designer, right? So Azure Machine Learning Designer, what this does is, so this is something in between notebooks and automated ML, right? So there are certain aspects that you have to do by yourselves, but you don't have to do the coding part, right? So this is a drag and drop solution, which basically leaves out the coding part, and this provides you with a certain set of tools you could use. You could shuffling between in order to achieve what you really want, right? So this is this is something that I have created previously, so I'll guide you through that, right? So first of all, what we do here is, so so in any machine learning problem we get to deal with a lot of data set, right? So if you look at this data set, if you look at automated pricing data set, so this is a publicly available data set. If you preview this, so if you look at this data set, so this basically is an insight onto what the data set means. So if you look at this data set, so there's normalized loss, there's make, there's fuel. So if you look at this, so there's Alfa Romeos, there's gas, there's aspiration as standard, number of doors, body style, drive. So what we are trying to do here is we want to predict the price of the car based on a certain set of features, right? So these highways mile per gallon, city mile per gallon, peak RPM, horsepower. So these are the set of features that we want to use in order to predict the price of a given car, right? That is what we basically want to do. So, but if you look at this data set, so you can see if you look at normalized loss for an example, so there is a lot of data missing here, right? So there is NA and B's not attended. So this basically means that these sets of data are not there, right? So these basically these are not here. So for this particular car, the normalized loss is not here, right? So if you use this a feature like this, it might actually hinder the accuracy of your actual machine learning model greatly, because there are certain values that are missing, right? But if you look at so are there any missing values? So if you look at this one, right? Here, if you look at this stroke, right? So there are 4 missing values. Only 4 missing values from all these sets of missing values, right? So what we can do here is, so if you compare to this one, normalized loss, sorry, stroke has really low number of missing values, only 4, right? So what we can do here is we can neglect the what we can do here is we can select set of columns, right? There's automated pricing data set, and we can select a certain set of columns to be our features, right? So if you look at this parameters, if you look at the data set, so I given column name as symboling, fuel type, aspiration number, body style, and so on, and as the columns that I have selected, right? So stroke, comparison ratio, and so on, right? And what I have done next here is, so as I explained earlier, so there are certain columns with missing values, right? So there are certain columns with, if you look at make, let's go back to make. Yeah. So here, so Bo has 4 missing values, right? So what we can do here is we can clean those data. We can remove actually the missing rows from the data set itself, where it will not actually affect that machine learning model that much, right? So what we did was we selected the set of columns that we want to be features, and if there are missing values, clean those missing values, right? What we have done here is that, right? So columns clean, bow, stroke, horsepower. So the minimum missing value ratio and the maximum missing value ratio I have provided here. And what I have done is basically that, right? So we have a proper data set, right? So why do we need to normalize it, right? So actually, what is the need, right? So we'll go back to the data set. So in order to understand that, so preview the data set. So if you look at curb weight, right? So curb weight is in the 2000s, right? 2000s, 2400, 2900. But if you look at something like, so there's peak RPM, which is in the 5000s. And if you look at this city miles per gallon, these are in the 20s, right? So if you create a machine learning model using these sets of features, so since these have a high value, when we're actually training the machine learning model, a higher weightage might be given to these sets of features compared to features with less number of values, right? So in order to overcome that, what we do is we normalize this data set. What normalization does here is, if you are familiar with statistics, what we do in normalization is, if there's a value x, we subtract the mean from it, and we divide the standard deviation, right? Standard deviation from it. So this will normalize our data set. Yeah, so this will normalize our data set, and it will provide, so I'll show you the normalized data set so you could get an idea, right? So yeah, complete preview data set, transform data set. So if you look at this, so symboling, Alfa Romeo. So if you look at this, right, curve weight. So the curve weight basically has a value between, so you could get statistics from here as well. So missing values, no. Frequency. So there's values between this and this, right? So there's minus this one and plus this one, right? So what they have done here is they have normalized our data set so that they don't depend on a certain set, a particular feature majorly, right? So that's what they have done. So after normalizing, what we have done is we have split the data set. So as I explained earlier, in machine learning, one of the practices that is performed is, so we split the data set. So in the previous example, we split the data set as 80-20, right? But here, what we have done here is we have split the data set 70-30 and use 70% of the data in order to train the machine learning model, and 30% of the data in order to validate the machine learning model. The scoring basically means validating the model, right? So what we have done is split the data in order to achieve that. So randomized split, random split. You could actually provide what you call certain parameters for this according to your need, right? So you could customize these based on what you actually want to be performed on your dataset. You could actually find these things from here. So if you go to transform data, let's go with transform data. Is it not proper? Features, let's say data transformation. So you could add columns, so you could actually create features by adding columns as well, by combining multiple features that are already existing feature. Apply mathematical operations, SQL transformation. So there's a lot of stuff you could actually perform on a particular dataset. So all the things that you can perform on Designer is here on this particular area, right? So so this is a drag and drop solution. What we can do is basically dragging and dropping here, and provide the sets of parameters that you want to do, right? And so what I have done here is I have split the data, and I have used the train model node, and I have connected the linear regression algorithm in order to train my node, right? So I have done that and trained the model. And what I have done next here is I have basically connected the remaining sets of data from there, the data set that I have split, and validated our data set, right? So this is basically a data set that I have validated. So this is basically machine learning design. So this is a no-code solution where you could achieve most of the things that you can actually do with code using nodes and drag and drop solutions that are out there. So yeah, that is Designer. So are there any questions on Designer? Right. If not, that is basically it for my session. So if there are other questions from Azure Machine Learning Studio as well, you could actually send them.
It looks like there are no questions, Saya.
I think, yeah. I
So
believe,
thank
yeah.
you.
I believe there aren't any questions, right? So yeah, thank you.
So thank you very much, Aya, for that concise and erudite speech. It was very informative and we learned a lot. So thank you very much, Aya. And guys, I'm going to drop a link in the chat. Please fill that link so we can send you your participation form. Give me 1 minute, guys. Okay, guys, please fill that form before you leave. And now I would like to wholeheartedly thank both of our speakers today for spending their valuable time coming here and sharing their knowledge with us. and just lighting up our whole evening. Thank you very much for those insightful and really knowledgeable speeches. And now, since we have come to the end of our meetup for the month of January, I hope to see all of you all again next month. So goodbye and good night, everyone. And thank you all for participating.